Hi everyone and welcome to this new class and this new section regarding flight mechanics. In this case we will be studying a bit of the ideas and the fundamentals of stability of an aircraft. So let's start by defining what is the center of gravity, okay? Most of you I guess already know, but it's kind of an important concept, so just checking, okay? This center of gravity is actually defined as the average point of all the mass distribution of a given aircraft. Okay, so you would have the tail, you would have the cockpit, the different passengers and cargo and all of that. And if you add all these masses, you would get a center of mass, okay? An overall geometric gravity center, okay? Now, the limits for the center of gravity must always be met, okay, and are defined in the flight manual. What I mean by this is that you cannot consider a center of mass which goes further to the back or further to the start of the aircraft, because if that were to be the case, the aircraft might become completely unstable. Okay, so if you are, for instance, allocating different passengers in an aircraft and there's not a lot of passengers, you cannot consider putting them all on the front, okay, or on the back, because that would destabilize the aircraft possibly due to the position of the center of mass. So it is really an important concept to take into account, and pilots and all the staff are required to check with the flight manual all the allocations of their passengers. Okay, this is important. Stability, okay, depends on the allocation of the center of mass, okay, the center of gravity, as I mentioned. So, as we said, passengers must be seated in a specific way. Now, let's define another concept, center of pressure. This is a really interesting topic, which is well discussed in all papers regarding aviation, okay, and regarding the stability of aircraft. And it's basically the center or the position at which all the force, all the lift that is produced by a wing can be considered to be applied to, okay? So the idea, as you can imagine, is that if we have a big wing, we would have different amounts of lift on different points on top of the wing, okay? But as an overall, as a kind of an average, we can consider just one point and the total amount of lift of that wing, okay, on one specific position. All right, this is a quite interesting topic because it is kind of a simplification, as you may understand, but it is quite useful to understand this in terms of stability of the aircraft. So usually it should be around 1/4 of the chord of the wing, okay, and this also depends on camber. So what do I mean with this? The idea is that the chord is the line which unites the front of the wing and the end of the wing, okay? So if I say it should be on 1/4, this means that it should be allocated quite on the front, okay, as you can see. 2/4 would be in the middle, 3/4 over here, right? So 1/4 is over here. The idea, this can be deduced mathematically and is usually approached for many problems, but the idea is that this kind of similar or kind of very, very close to 1/4 of the chord, okay? This especially depends on the geometry of the wing itself, okay? It depends on the camber. So actually the form, the geometry of the wing, right? What else? Stability, okay, depends on the allocation of the center of pressure. And it actually depends by comparing the center of pressure, the position of the center of pressure, with, okay, the center of gravity. So basically you have to compare one to another. Let's see this. Okay, so here we have some illustrations of what this would look like, okay? Let's see. The center of gravity should be located closer to the front for stability purposes. Okay, this is kind of a definition of stability. I'll just take a minute to talk about stability, but before I want to kind of relate what the tail and the lift actually do, okay? So first of all, in an aircraft, as we mentioned before, we need an equilibrium of forces. We need the lift, we need the weight, we need the drag, and we need the thrust, right? So all these forces should be completely equilibrium. Now, the aircraft should also consider an equilibrium in terms of moment, okay? And what I mean by this is that a moment, I don't know if you know this, but a moment is defined as the force multiplied by the distance of the force, okay? The perpendicular distance of the force respect to the center of rotation. So, as I said, rotation, okay, of the aircraft actually takes place around or respect to the center of gravity. So this is why the center of gravity is so important. You can imagine this aircraft, okay, moving in any way, but respect to the center of mass, okay? Now, the idea here is that if we need moment equilibrium, we need all the moments to compensate one another, okay? The same way that the lift and the weight had to be the same, so that the sum of the lift and the weight would be 0. Now what we need is that the product of L times the distance of L, okay, which I defined as dl, should be actually equal to t, alright, multiplied by the distance of t. So, first of all, you may notice that t has to be defined in the negative direction, okay, because the lift is defined in this way, and the lift would actually imply that the aircraft moves in this direction. However, if we need to compensate for this movement because of the lift, okay, we have to compensate it with a tail force, okay, a tail lift, which actually goes in the opposite direction. Why is this? Well, because if you had the tail going up also, you would have a very severe movement of the aircraft. You would see that it is completely unstable, you see? So you need one to compensate the other. And the second idea here is that the lift is very bigger, okay, it is much higher than the tail, than the lift on the tail. Why is that? Well, the idea is that you have to compensate for the moment. Okay, so L times dl should be the same as t times dt. And as you can see in this image, dl is very, very lower compared to dt, okay? So in the end, you end up with a lift which is very big and a dl which is quite small, and a t which is kind of small, okay? But a dt which is very large compared to the dl. So this is kind of what you need to know in terms of equilibrium of the moment, okay? Let's see now how this actually affects stability of the aircraft. Now, depending on the position of the center of gravity, our aircraft will be stable. Okay, so to understand this, what I propose is that you actually look for this over here. Okay, imagine that you have a point, all right, or that you're, I don't know, this could be a ball, could be a heavy ball, could be some metal, okay, ball, and you're holding the ball from this point. So imagine your fingers over here kind of supporting the weight of this ball, okay? You can imagine that, and this works as a pendulum, okay? So you could actually move the ball and it would be stable regarding the center of rotation over here, right? Okay, it would move this way. Now imagine that you have that you actually you know, the ball is over here on the top, okay, and you're holding the ball on this point, which doesn't really make sense, does it? Right? Okay, so the idea would be, considering that this would be a solid beam, okay, in this case you would actually have completely unstable movement. Okay, and why is that? Well, the idea would be that if you're trying to hold this ball from below, if you try to move the ball a bit, the ball will completely fall and move to the other part, right? Would move to the lower part, okay, and would start rotating here. And why is this? Well, this is the basic of stability. So it depends on where you're holding the ball and where the ball is actually moving, okay? This would be completely unstable, this element over here, as you can see, as you can imagine, okay? And this one would be stable because it would rotate, but it would be in, you know, it would be kept in a certain range of angles, okay? So it would rotate, but it would be stable, and this one would be unstable. Okay, so why am I talking about this? Well, the idea is that the position of the center of mass is actually where we would be actually holding the ball, okay? So we would kind of imagine that we are holding the aircraft in this point over here. So if we have a perturbation, okay, of the lift, for instance, so if the lift were to increase a bit for one moment, you can see easily that the aircraft would actually move. But since the center of mass is on the front, right, respect to the velocity, okay, respect to the velocity that would be coming over here, you can see that it would automatically kind of stabilize, alright, over here. So this is the same idea as this one over here, okay? In addition, as you can see, the lift and the tail would have the different directions, okay, because we have to compensate the aircraft. And if there's a perturbation in the lift, the most possible, well, probably the tail will automatically compensate for that, okay? Now, let's see the other case. The case that we have the center of gravity actually positioned farther away from the front of the vehicle, okay, than the lift, okay? So let's say now the lift increases a bit. So if you imagine that you're holding the aircraft on this point, what would happen is actually the aircraft would start to rotate, and unless the tail can provide stability, which probably wouldn't, okay, the aircraft would just completely unstably, okay, just move around in the same way that we defined this over here, so, right? So imagine taking the aircraft on this point, holding the aircraft in this point, and actually putting an additional force to this. So the aircraft would be completely unstable considering the velocity, right? It's pretty clear, I think. If you have any doubts regarding this, just let me know, and I'll make sure to send to you some more examples and ideas on stability, okay? Because it is an interesting topic. And it is very important, of course, for aircraft that they are stable. In fact, if you wanted to know, there's also military aircraft which are designed for them to be unstable, okay, naturally unstable. And this is because it may improve the maneuverability, okay, of the aircraft itself. So sometimes it may be interesting for us to make the aircraft unstable, but as you can imagine, as in terms of a commercial aircraft, of course, we need it to be incredibly stable, okay? What else? Yeah, so if we define the center of gravity, as we mentioned, after the center of pressure, okay, then the aircraft is naturally unstable. Even though the tail may try to stabilize it, but the aircraft is unstable, okay? So this is what you need to know.